This is Alphonse Murungaru, and I'll be talking to you about the domain name system. This is for my class ISA 4220. What is a DNS? The domain name system is one of the industry's standard protocols that they comprises of the TCP and the IP. The DNS is implemented using two software components, usually the DNS server and the DNS client, or the resolver. Both of these components run in the background as service applications. Network resources are usually identified by IP addresses, but these IP addresses are difficult for network users to remember. So the DNS database will contain the records that map these IP addresses and to make the network resources easier to remember for the network users. There are two main types of servers. We have the caching and the authoritative. The authoritative servers map the URL to the IP for a domain. They're the source of information that the recursive DNS servers send to the web client, like browsers. Authoritative DNS servers for websites are usually provided by web hosting companies. And you also have the caching or the recursive DNS servers. When your browser sends out a DNS query, assuming that the browser doesn't already have the mapping stored in its cache, it is sent to the recursive DN server. The recursive servers are part of the DNS that provides the required information to the client. They're usually managed by ISPs or the organization that owns the domain of which the connection is being made. For the DNS domain names, it contains various types of data. Some types of domains that we have are the root domain, the domain name system is usually implemented in a more of a hierarchy, and is distributed through the database while containing various types of data, which mainly will include the host name and the domain names. The domain names form a type of a tree structure called the domain namespace. The domain names consist of labels separated by dots. For example, when you have a domain like mydomain.microsoft.com. Moving on, a fully qualified domain name uniquely identifies the host position within the DNS hierarchy by specify the names separated by the dots in the path to be referenced by the root. To better understand how the domain name works, some types of domains that we have is the root domain. This is the top of the tree, which represents an unnamed level. It is sometimes shown as two empty quotation marks, indicating that there is no value. When used in a domain, it is stated by a period to designate the name that is located. The DNS domain name is considered to be complete at the point to an exact location in the tree of the names. We also have the top level domain, which is a name used to indicate a country, region, or type of organization using a name. We have the second level domain. These are names registered to an individual or an organization for use on the internet. These names are always based upon an appropriate top level domain, depending on the type of organization, the geographic of the location in which the name is used. Moving on, we have the subdomain, additional name that an organization can create, which are derived from a registered second level domain name. This can include names added to your DNS tree of names and divided into departments or geographical locations. Last but not least, we have the host or the resource name. These they represent a leaf in the DNS tree of a name and identify a specific resource. Typically, these are the leftmost labels, which identify a specific computer or the network. The DNS query. The DNS resolution, the first step, you open your web browser and you enter the web address. At that point, the computer doesn't really know what the web address is. So it will send a DNS query to our ISP's DNS server. It's querying the ISP's DNS. The reason it's sending this is because it's being set through our steps of properties. The second step, it will be your ISP's DNS server doesn't know what the IP address, so it will ask for one. It will ask one from one of the root DNS servers. The third step of the DNS query, the root DNS server checks its database and finds that the primary DNS for the web address you sent, and then it will reply to your ISP with an answer. Fourth step, your ISP's DNS server now knows the IP address of the web address of the DNS server, so it will send a recursive query to the DNS server asking to resolve the fully qualified domain name. Then the DNS server checks its database and finds an entry for the address you inputted. The entry of the IP address, since they will be identical, they are likely to be both the same physical server. Load balancing mechanism can also have the same effect, making multiple services and physical machines to have the same IP address. Your ISP's DNS server, now known as the IP address for the web address you put in, sends the results to your computer. Last but not least, the last step, step number 7, your computer now knows the IP address of the website and it's able to directly contact it. Naturally, the next step will be to send a HTTP request directly to the web server and download the page. DNS has what sometimes will be referred as a global distribution. What this means is that the DNS lookups can be performed by any device. The remote DNS data is locally cacheable, and the data can also be maintained locally, but also retrievable globally. What that means is that one single computer can have all the data. Not one single computer can have all the data. Some of the zones of the DNS include the zones are responsible for administrative spaces. And what a zone is a portion of the DNS database that contains the resource records with the owner's name that belong to the portion of the DNS namespace. Zone files are maintained on the DNS server. A single DNS server can be configured to host 0 or multiple zones. Each zone is anchored at a specific domain name referred to as zone's root domain. A zone contains information about all names that end with the zone's root domain. A DNS server is considered authoritative for name if it loads the zone containing the name. The first record in any zone file is the start of authority. The SOA identifies the primary DNS name server for the zone as the best source of information for the data within that zone as an entity processing the updates for the zone. The primary reasons to delegate the DNS namespace are you need to delegate a management for a DNS domain to a number of organization departments within an organization. You also need to allow for a host of organization affiliation by including them in the appropriate domains. Last but not least, you need to distribute the load maintaining one large DNS database among multiple DNS servers to improve the name resolution performance as well as create a DNS fault tolerant environment. Some of the best practices to securing and better protecting your DNS server is to limit your IP addresses. You also need to disable the recursion. You need to use the UDP source port randomization in the bid. And last but not least, you can implement some IP guard. How to do this? To disable your recursion, open your DNS using the following procedures. And once you get into the console tree, right click on the DNS server that the recursion will be disabled for, and then select the properties. The next thing you need to do, you need to click your advanced tab within the server options, and then select the disable recursion checkbox on the left, and then you click the access control list. Here you can provide static anti-spoofing protection against any untrusted address space. How you do this? This is an example of how you can use it to limit your IP and to limit any IP spoofing. The access control list can be applied for the inbound at any desired interface. Yeah. That would be the end of my presentation, and these are my references. Thank you.